Okay, so welcome to today's class, everyone. So our first question for today, it is a trigonometric identity. Okay, so this is a question which came and they were telling us to prove the trigonometric what identity. So whenever they tell you to prove most of the things in mathematics, when it comes to foundation mathematics for university, you need to understand that you have two sides. Okay, this is an equation. Okay, there's an equation here. So there's this side, okay, which is the this side, it is the right hand side, and then this side is the left hand side. So we pick a side. Which side are we going to pick? We pick the most complicated side. That is the side we're going to pick. Most complicated. Okay, that is the side that is picked. So from here, so we pick a most complicated side and easy to solve. Okay, and easy to solve. So the one which is easy for you to solve, it is this one, and it is more complicated because it requires more simplification for it to be like this. Okay, so but it is difficult for you to come from this side going this side. It's a bit difficult. So you pick the most complicated and easy for you to solve. So this one, I'll say taking the left hand side. Okay, so if I take the left hand side, which is cot x cosec x over sec squared x plus cosec squared x. Okay, it is equals to cos 3x. All right, so having this, so I have taken this side, the left hand side. So now my goal, it is to go to this side. Okay, so what do? You need to understand that cot, cosec, and sec, these are reciprocals of what? Trigonometric functions. For example, cot is the reciprocal of what? Of tan. Okay, so and cosec, it is the reciprocal of what? Of sine. Okay, then sec, it is the reciprocal of cos. So knowing this, you're going to say, okay, this is the question. You're going to rewrite this in that form. You're going to say that this is 1 over tan x. Okay, then it is multiplying. So I'm on this one on top, cot x. Then I'll get this one, which is the same as 1 over sine x over, here at the bottom I have sec squared. So it's the same as having 1 over cos squared x. It is adding with 1 over sine squared x. Okay, so after having this, we are going to come here and we're going to say that this is the same as 1 over tan x sine x. Then it is dividing with over 1 over cos. So here I'm going to get a common denominator. Okay, so here I'll say that here my common denominator, it is at the bottom, it is it will be the multiplication, it will be sine squared x cos, just a minute, so sine squared x cos squared x. That is what I'm going to have as my common denominator. Then on top, I'm going to have sine squared x plus cos squared x. Okay, so looking at the way this is, you are going to realize that sine squared x plus cos squared x, it is an identity. Okay, so this is an identity which is equivalent to what? To 1. Okay, so what we are going to do is that we're going to replace this part with 1, and we're going to say that this is, so for easy solving, I'll do this. I'll say 1 over tan x sine x divided with sine squared x plus cos squared x over sine squared x cos squared x. So after having this part here, it is what? It is equivalent to 1. So what we're going to do is that we're going to say that this is 1 over tan x sine x, okay, is dividing with 1 over sine squared x cos squared x. Okay, so after reaching this point, you know that if you have division here, you're going to say 1 over tan x sine x times sine squared x cos squared x over 1. Okay, which is just going to give us sine squared x cos squared x over tan x sine x. When you reach this point, the end answer is supposed to have cos only, cos to the power 3x. So your duty now, it is to remove the tan and the what? The tan and the sine. Okay, that is your duty. So here, the one on top here, we know that this one here, or the one here at the bottom, okay? Let me start with the one at the bottom here. The one at the bottom here, this is tan x. So tan x is multiplying with, sine x. Now tan x is sine x over cos x, and it is multiplying with the sine x, meaning that this is just the same as having sine squared x over cos, okay, which is cos x. So here at the bottom again, now I have sine squared x over cos x. So it's the same as I have sine squared x cos squared x over sine squared x over cos x, which is just the same as saying that this is sine squared x cos squared x over, oh, so I move the over, I say divide with, this one is sine squared x over cos x. So when I reach this point, I'm going to say that here I change this to multiplication. I'm going to have sine squared x cos squared x times the cos comes on top and the sine comes at the bottom. So the sine squared x is going to cancel with this. As a result, I'm only going to remain with what? With cos squared x, which is going to multiply with cos x. As a result, it is going to give me an answer which is what? Cos, which is identical to the right hand side. Are we together?
Yes.
Okay, so that is how you prove identities which are of trigonometry in nature. Okay, anyone with a question?
Excuse me, sir. Can I ask you a question?
It's clear?
Sir, is this class going to be posted on your YouTube channel?
Yes, I'll send it.
All right, sir. Thank you.
All right. Okay. So we continue. Okay. So now let us look at another question. Okay. So this is one of these are those questions which they usually bring. Most of the times they usually bring these ones. Sketching. Okay. So when they tell you to sketch a trigonometric function, what you need to realize is that the first question they're going to ask you is to say find the amplitude, the period, and the phase shift. They can even tell you to calculate the vertical shift. Okay, so starting with the first one, so each one of these is 1 mark. So this question is a 3 marks question. Okay, so after finding all these, you will get your 3 marks. So make sure you get these ones because these ones are easy to find. So starting with the first one, I'll say I. Okay, so starting with this one, I'll say amplitude. How do I calculate for my amplitude? Okay, so for my amplitude, I am going to say that it is the absolute value of A. Okay, now what is my A? So in a trigonometric function, which can be written as g of x or f of x or y, is equals to A, in this case the sine, so I'm going to write A sine, then I'll write bx plus c, okay, then plus d. This is the general formula of what? A trigonometric function. Okay, so you can have sine, you can have tan, you can have cosec, you can have sec, you can have cot, whatever you might have there, as long as it is written in this form. So now, this is how you get your A. So now, you're going to realize that A, it is just a coefficient that is found in front of the trig function, okay, which is A. So, in this case, we have y is equals to negative 3 sine x minus 90. Okay, that is, so what is our d? Our d is 0 because it is not there. I think that's why they didn't even ask the question to say calculate the vertical shift. So for the amplitude, you get the A and you find the absolute value of it. So amplitude is equals to the absolute value of A, which is, in this case, it is what? It is 3. It is negative 3. So it is negative 3 here. Therefore, so I'll write it here for space. It is negative 3. As a result, my amplitude is equals to a 3. Then I go to the period. Okay. So period, it is gotten by saying that period is equals to 2 pi over b. In this case, since we are using angles, we're going to say that it is 360 divided by what? By b. Because this one is just in radian measure and this one is in what? Degrees. So what is our b? Here we have our A is equals to negative 3. Don't forget, our b is equals to, it is the number that is in front of the x, which is just 1. Okay, so our b here in this case, it is what? It is 1. So meaning that our period is going to be equal, so we're using degrees, so it's going to be 360 over 1. It is equals to 360. So what does the period tell? The period only tells us to say that this is how much it's going to move, okay, for a complete what? For a complete wave of what? A trig function. Okay, that's what the period tells us. Remember from the period of a pendulum from high school, we used to say that a period of a pendulum, it is the time taken for one complete oscillation. So even this one, they want you to have an answer that is up to a certain period. Okay, if they don't give you a limit. But for this case, they've given us a limit. Okay, don't forget that. Okay, so on this case, you found the period. Now the phase shift. Okay, how do you get the phase shift? So phase shift, you're going to say that the B plus C, okay? So BX plus C, you're going to equate it to what? To 0, okay? You're going to equate it to 0. So after equating it to 0, you're going to say, so here in this case, we have X minus 90, okay? X, so X plus C, which is what? Negative what? 90, okay, is equals to 0, meaning that it's X minus 90 is equals to 0, meaning that our X is equals to positive 90. So it is a positive, so it is a right what? Right shift, okay? The graph is shifting to the what? To the right by 90 degrees, okay? That is what it is only telling us. The vertical shift is only telling us that the vertical shift tells us if it is either moving up or downwards. Okay, so it is 90 degrees in this case. Are we together here?
Yes.
Okay. Now the next question they are telling us to do is to sketch the graph for what? For 0, okay? 0 is less than or equal to X is less than or equal to 360. Okay, so that is what they want us to sketch. So what do? So you have your function, which is y is equals to negative 3 sine negative 3 sine X minus 90. Okay, then you have this side, you have there's nothing this side, so I mean there's no vertical shift. So this is they want you to sketch this. So now what are you supposed to know when you're sketching? You're supposed to know the normal graphs. Okay, for example, the sine graph. Okay, so since here there is the sine, so so we're going to check the sine graph. The sine graph under normal circumstances, it is usually 1, negative 1, 0. Okay, 90, 180, 270, 360. Then it moves from here, it touches here, it comes here, it goes there, it reaches there. Okay, that is the normal sine graph. There's also for cos, there's also for tan, but in this case, let's focus on sine. Okay, so in this condition, we've already calculated the period. Period, we've said that it is what? It is 360 degrees. Our amplitude is equals to a positive 3. Okay, then our phase shift is equals to 90. Okay, X is equals to what? To 90, meaning that it is shifting to the right by 90. So then the other thing that you need to also know how to calculate, it is the vertical shift. Even if they didn't ask you here, they can ask you. Okay, so how do you calculate vertical shift? Vertical shift, you just say vertical shift is equals to D. So whichever value they'll give you, whether it's positive or negative, that's your vertical what? Your vertical shift. Okay, so in this case, since we didn't have a vertical shift, meaning that there's plus 0, meaning that in this case our vertical shift is equals to what? To 0. Are we together? There is no shift. Is everyone here? So you can just confirm with me by responding, so that I know that everyone is still there. Hello? Is everyone there?
Yes, we are able to get.
All right, wonderful. So These are the things that you need to know. Then now, there is an important feature we are supposed to know when you're sketching. It is what we call the scale. Okay, you know that when you're finding anything to do with graphs, you have a scale. So scale is equals to period over 4. So the period in this case, it is 360. So it is 360 divided by 4, meaning that our scale is equals to 90 degrees. So meaning that after 90 degrees, okay, the graph will be turning. That's what the scale tells us. So in this case, we are going to start, we're going to write this. So since there's no vertical shift, so meaning that I'll just write like this. But if there was a vertical shift, there was a way I would have written it so that I can accommodate the numbers that will be added or subtracted. Okay, but in this case, since we don't have a vertical shift, I'll write it on the middle there. Then now, my amplitude I have, so my amplitude is 3. So meaning that I'm going to have the limit, the upper limit I can have, it is a positive 3. The lower limit that I can have is negative 3. Then here I have a 0. Okay. Then now, the scale. The scale is telling me that it is what? 90 degrees. Meaning that after 90 degrees, so 90, so I'll start from here. 90, 180, 270, 360. These are the what? These are the points of which are what? Critical. Okay. So now I'll start plotting. So I already know. So what I'll do, I'll write with a red ink first to show you. So under normal circumstance, the normal sine graph would have gone like this. Okay. Reaching the 3, because the amplitude has changed to 3, so it will reach the 3, then it will turn, it will touch here, it will touch there, then it will come here. Okay, this is how it would have been normally, right? So you can just be responding so that we
Yes, sir.
together. Yes, it would have been like this. That's how the normal sine graph would have been. Now, in this situation, it has a negative in front. Okay, so what it's telling us is that this one is inverted. Okay, so because of that negative sign, it is inverted. So the inverted one, meaning that it will be the opposite. If here it was positive 3, if it was 0, it will be 0, right? If it was 3, it will be negative 3. So meaning that this point will come here. So it's going to be like this. Because of the negative sign, so let me just write it, the invisible. Okay, that's how it would have been. Or that's how it's going to be inverted. So it's going to be a mirror image of the normal sine graph. So now, after you've identified that, what is your phase shift? Your phase shift, it is a 90 degree to the what? To the right. So meaning that if this point was here, it is going to shift here. So you add, so meaning that if it's positive, meaning that it's going to be moving to the right side. So meaning 0, you're going to add a 90. Then meaning that the point, I'll use black. So meaning that the point will move this point which was here. Okay, so meaning we are focusing on the green one because the first one has already served its what? Its purpose. It's for us to draw the one which is in green. Okay, so therefore, if here there's a 0, I'll add the 90, meaning that this point which is here will come here. Okay, then this point which was here negative 3. Okay, when it was 90 here. Okay, when it was 90, it's going to shift. This point which is here is going to move to this point here. Okay, it's going to move to this point. So meaning that this point which is here, it will come here. Meaning it will come here. Then this point which is here, the 180, it's going to go to the 270. So since you're adding by 90 every point, then this point 270, where it was standing here, 270 was here on top. So meaning that this point is going to go to 360. So meaning that this point which is here will come here. Okay. So when you see that, you're going to connect these points. Then now, okay, so we've drawn this line. Okay, now check the limit they've given us. So on 360, we know that that's the upper limit. We've ended there. Okay, so no need of doing anything this side. So we'll reach there. Now, if you check the limit they gave us, they say that it is from 0 to 360. Okay, and where 0 and 360 are what? Included. So you're going to come here and you're going to say from here we need to reach the 0. Okay, so this point you're going to connect on because you know that it's going to go up. Okay, so it will come here, and therefore you have sketched a graph of y is equals to -3 sine x minus 90. So these other ones you can just rub them. They are not important now because they have already served their purpose. It was to help us solve for us to sketch the graph. So you can just rub it off. So you can use a pencil to do this, to do these other inks, okay, as you are sketching. So this is your answer. Are we together?
Yes, sir.
Okay. So we're done with this question. Let us go to another question. Okay. So for those who are doing 1100, you also have the first principle. Okay. So when they tell you to differentiate using the first principle, you need to know the formula. Okay, because this is the definition of differentiation. Okay. So when they tell you to find using the first principle, you need to understand that the first principle, it is solved by the formula limit as h approaches 0, okay, for f of x plus h minus f of x over h. Okay, this is the definition of the first principle, differentiation. So now you cannot plug in the 0 in here. Okay, but before I do that, okay, let me explain first. You cannot plug in the 0 here because it will make this entire thing what? Undefined. So what you do is this. You're going to say that limit as h approaches 0. So now, don't get confused with this, because f of x plus h, what they just mean is that we know how to replace. For example, if you have f of x, then you replace with f of a. You know what you mean there, meaning that where there's x, you're going to replace with what? With a. So now, if you have x plus h, meaning that where there's x, you're going to replace with what? X plus h. So in this case, you have this function which is f of x, which is 1 over the square root of 1 minus x. So you're going to say that in this case, the limit as h approaches 0, this one f of x plus h, which you know that it is just this, which is here, you're going to replace it with what? You're going to replace the x with x plus h, meaning that you're going to have 1 over the square root of 1 minus x. So I'll write it in brackets so that the sign can be for both. Okay, like that, to avoid errors. Then I'm going to say minus the f of x. What is f of x? F of x is 1 over the square root of 1 minus x, okay, over h. Okay, so after replacing there, I'm going to continue by saying limit as h approaches 0, which is 1 over, I'm going to have the square root of 1 minus x minus h. Okay, then minus 1 over the square root of 1 minus x. Okay, over h. So we know under normal circumstances for a limit, by definition, we get a certain value when we replace a certain number where it is coming close to. Okay, we get a certain value. So we usually replace that number which it is going close to. Okay, so in this case it is 0. So because it is 0, when we replace 0, it's going to become what? Undefined. So for you to avoid all those errors, let us first simplify this. And so before I do that, let me just go to the other page. So I open another page. I'll say limit as h approaches 0. I have this side. So this side, I'm going to find the common denominator. Okay, so that I can simplify what is on top. So I'm going to find the common denominator here, which is just so I'm going to have the common denominator there. I'm going to have, it's going to be the square root of 1 minus x minus h. Okay, and the other one is going to be 1 minus x. Okay, then on top I'm going to have this one here. On top I'm going to have this multiplying with this. Okay, and then I'm going to have the square root of 1 minus x. Okay, then here at the bottom, the other side, I'm going to have minus the square root of 1 minus x minus h, okay, over the h. That is what I'm going to have. Okay, so when I reach this point, I know that the h here, since I'm dividing, okay, since I'm dividing, the h, this one can come here. Okay, it can be like this. I'm going to have limit as h approaches 0. It's going to be the square root of 1 minus x minus the square root of 1 minus x minus h over the h comes here, okay, in front of this. I can show this. So let me just is everyone clear before I show it, or I should show it why I'm saying the h is coming here?
Very clear, sir.
Oh, okay, all right. So the h will come here. It's going to be 1 minus x minus h. Then I'm going to have 1 minus x like this. Okay, it will come in front. Then now, when I reach this point, I'm very close to solving, but I can still not replace the what? The 0, because if I replace the 0, this everything here is going to become what? Is going to become a 0. Okay, so my duty now, it is to make sure that I simplify this in such a way that the h at the bottom can be what? Can be cancelled. Okay, so how do I do that? I conjugate, or I rationalize. In this case, I want to rationalize the denominator. I'll rationalize the numerator, because the numerator, it is the only way we can cancel the h, because if we have an open h on top, we can just cancel and have our what? Our derivative. Then, meaning that in this case, when we rationalize our numerator, it's going to be the square root of 1 minus x plus the square root of 1 minus x minus h over the square root of 1 minus x plus the square root of 1 minus x minus h. So after doing this, you are going to realize that here on top is going to be limit as h approaches 0. Here, this is a difference of two squares. So you're going to find out that on top you have this one multiplying with this. It's going to give you 1 minus x. Then you're going to say minus. Then when this multiplies with this, is going to give you 1 minus x minus h. Okay, like that. So I've added in brackets because of this negative sign which is here. It has to multiply with everything that is going to come out there. Okay. Over at the bottom here, I'm going to have the h. Then this will multiply with everything. So I'll do this. This multiplies with everything that is here. Okay. Or let me just say that it's going to be h, because this one is 1. I'll do this for easier solving. Okay, since this is 1, it's going to multiply with these which are 2. So it's going to be the square root of 1 minus x plus the square root of 1 minus x minus h, like this. So after I reach this point, I can still not what? Replace. So what I'm going to do, I'm going to say that limit as h approaches 0. Here I'm going to have 1 minus x, then minus 1. Then this one is going to be plus what? Plus x plus h. Okay? Over here on top, or here at the bottom, I'm going to have h, the same one. So I'll just write it the same way it is. Okay? To avoid spending much time simplifying this. Okay. So here I have this now. The square root of 1 minus x plus the square root of 1 minus x minus h. Okay, so after I reach this point, you're going to realize that this is 1 minus 1, it is 0. Negative x plus x, it is what? 0. Then I'm going to only remain with what? With an h on top. As a result, I'm going to have limit as h approaches 0. It's going to be h over the h, the square root of 1 minus x minus h, the square root of 1 minus x, and then here I'm going to have open brackets, the square root of 1 minus x plus the square root of 1 minus x minus h, like this. Okay, so here you're going to realize that now you have an h on top, you have an h at the bottom, and these are multiplying. These can do what? They can divide. So on top I will remain with a 1. I'm going to have limit as h approaches 0 is equals to 1 over this one here, 1 minus x minus h. Okay, then here I have 1 minus x, then here I have the square root of 1 minus x, okay, plus the square root of 1 minus x minus h. That is what I'm going to have. So when I reach this point, I'm going to say that limit as h approaches 0. In this case, I'll have 1. So let me do this. So here I can just go to solving now, since now I can just plug in. So I get the 0 now because I know that even if I plug in the 0 here, it cannot make this function to become what? Undefined. So I'm going to replace the 0 on h. I'm going to have 1 over the square root of 1 minus x minus 0, the square root of 1 minus x, and then this side it's going to be the square root of 1 minus x plus the square root of 1 minus x minus 0. Okay, I'm going to have that. As a result, it will be equals to 1 over This one here, I'm going to have 1 minus x multiplying with the square root of 1 minus x. Okay, then it is also multiplying with this 1 minus x plus the square root of 1 minus x. Okay, so therefore if I have this, I'll just say this is equivalent to 1 over, since these two are multiplying and they are square, so the square roots are going to break. I'm going to remain with what? With the 1 minus x. Okay, then here when I add these two, they are the same, so it's going to be 2. Okay, 2 the square root of 1 minus x. Therefore I have this. So after I reach this point, I'm just simplifying now. 1 over this multiplied is going to be 2 the square root of 1 minus x, and then now again this multiplied, this is going to be negative 2x the square root of 1 minus x. Okay, therefore you have this, which you can just simplify further and just say that this can also be written as 1 over let me just say, so I'll write O. So you are done here. Okay, or you can write it to say what is common there. Going to say 1 over what is common here, it is the 2 the square root of 1 minus x, and then you're going to write it is 1 minus x. Are we together? Okay, so but it's better just leave it here. This is very, very, very fine. Therefore you've differentiated. Anyone with a question? Okay, if there's no question, I'll assume everything is what? Clear. Okay. All right. So our other questions for today, which will be the last questions for today, these ones. Okay. So this is also on limits, and we have been given this question to say evaluate the following what? Limits. Okay, so let's come here. Okay, when we have this, okay, when we have this, then they are saying that what is the limit when x approaches what? Approaches infinity. Okay, so here so there's a rule which you apply. What is 1 over x? If I was to ask, when you have 1 over x squared and 1 over x as x approaches infinity, hello? Is everyone there?
Yes.
Yes. What does it give you? What does it give you? So I limit as x approaches what? Infinity. Okay, for x squared, for x to the power 3 minus minus 3x plus 2, okay, over 3x to the power 3 minus 4x. Okay, so when you have this question, the best thing that you do is you divide out, okay, so that you can dismiss out some certain things that are going to make the what? That are going to make the function to become what? Undefined. Okay, so that is what you do. So in this case, you're going to divide out the what? The highest degree here. Okay, that is what you're going to divide out. So in this case, you need to know that when you have this 1 over x to the power 2, it is equals to 0. Okay, so that is one thing you need to note. Okay, so when it is approaching infinity, and this case it is positive infinity, the values that you'll be dividing, so here when you divide out, you're going to say that this is equivalent to, and you say that limit, I've written limit here. Okay, so limit as x approaches infinity, you're going to divide out the what? The highest degree. In this case, it is x to the power what? X to the power 3. So you say x to the power 3, you divide it out, then you're going to have 1 minus 3 over x to the power what? Power 2. Then this one is going to be plus 2 over x to the power what? 3 on top. Then at the bottom, you're going to have what is the highest degree? It is x to the power 3. Then it's going to be 3. Okay, then into this, it's going to give you minus 4 over x to the power 2. Okay, so because for the fact that x to the power 2 gives you a 0, okay, or 1 over x to the power 2 gives you a 0, this is just telling us that these which are here, they are just the same as what? As 0. Okay, so this and this will cancel. You're going to have limit. You're going to say this is equivalent to. So when this becomes a 0, you're going to have 1 minus 0 plus 0 over 3 minus 0. Then this will be equivalent to 1 over 3. Okay, are we together? That's your answer. Are we together, everyone? So you just respond so that I'm able to just to confirm. Hello? Is everyone still there? All right. Wonderful. So that's how you solve this question. Let's solve 2. So 2, it's saying that what is the limit what is the limit where limit of as x approaches negative 2 to the power negative, so h of x. So this is h of x. Okay, so now you've seen that here they've said that from the negative side. Okay, so when you're solving this question, you know that so outside 2. So 2, when you're solving it, when you're finding the limit as x approaches, this is a piecewise what? Piecewise function. Negative 2. Okay, from the negative side. So we know that when you're finding limits, you usually replace this number, okay, on the function that they've given you, then you get the solution. But this is a direction, because limits have what? Direction. So because limits have direction, you're going to say that, okay, what is the limit as x approaches negative 2 to the from the negative side? So here you come here and examine which one is coming from the negative side. This one is saying that x is less than what? Negative 2. And this one is saying that x is greater or equal to negative 2. So which one of these two is coming from the negative side?
The first one.
The one on top, right?
Yes.
Okay. All right. So you pick this one, and that's what you're going to write here. Okay? Negative 2x minus 4. So this is a function what they want you to find. Therefore, you're going to say this is going to be equals to negative 2. You plug in the negative 2 there, and you say minus 4. Therefore, this will be equals to positive 4 minus 4. As a result, it is equals to what? To 0. Are we together? Are we together, everyone? And you're done with it? Yes. Okay. And you're done with limits. So we've gone through different questions. So this is what they usually like. Yeah, they like bringing first principle. Yes.
Could you kindly repeat the question 2?
Oh, 2. Oh, okay. So on 2, what we do is that when you're solving 2, we usually get to say that limit as x approaches negative 2 from what? The negative side. The negative on top is telling you that it is coming from what? The negative side. It's not part of the number. Okay, it's just telling you the direction. So from here, this is a piecewise function. It has two. This one is when it is less than negative 2, and this one is when it's greater than or equal to negative 2. So you use these equations differently. So if it had a plus here, we would have used this one. But since it has a minus, we are going to use minus. Okay, we're going to use the one which is less than what? Negative 2, because that is the one which is less than. That's the minus, what it means. Okay, so meaning that we're going to pick this. And we usually plug in the number that we have been given on finding limits. So that's what we did. We just said negative 2. The x we plugged in to say that it is what? Negative 2. Then minus 4. Then negative 2 times negative 2, it will be positive 4. Minus the 4, it is equivalent to what? To 0. Are we together?
Yes, it is clear now.
All right, wonderful. So limits, you can go through a number of examples. There's even plotting. Plotting is not any different from modulus. Okay, the way you plot modulus, that's how you plot even these ones. Okay, then there's also continuity. Okay, those three rules for you to find if a function, if a limit is what? Continuous. Okay, the limit has to exist. Number 2, the limit has to exist. Then there's also another one which says that f of x must be equals to the limit. Okay, so all those things, take them in their 3 rules. So just go through them, and you're going to I've just forgotten one rule. Yeah, but go through it. They can also ask you to check if a function is what, if the limit is what, is continuous. So those three rules, they're the only rules to apply. The limit has to exist, and yeah, I've remembered too. Limit has to exist, and the limit and the f of x have to do what? Have to be equal. The other one, yeah, you can go through it, that one. Okay, just a search on it. Yes. So otherwise, thank you very much everyone who's attended. So thank you very much. So